start with 1 mark questions. Okay, so question number 1. So question number 1 says, if an event that cannot occur, okay, then its probability is, okay, now I think everybody has got this answer, but it has options. So 1, then B is equal to 3 by 4, C is equal to 1 by 2, and D is 0. Okay, so we know it cannot occur, so my probability will be D 0, because it's an impossible event which cannot occur. Okay, let's go to question number 2. So question number 2 says, a die is thrown once. A die is thrown once. Find the probability. Find the probability of getting at most 2. Okay, so in this, okay, at most 2 is in bracket. So this we have to see that at most means, okay, let's see, if we throw a die once, then what are the outcomes? 1, 2, 3, 4, 5 and 6. So at most 2 means this will not include only 2. At most 2 means it can include 1 also, correct? So then I can say, we know the formula, but it is a 1 mark question, so no need to write down the formula. We can say probability of getting at most 2 will be equal to 2, because favorable outcomes are 2 and total number of outcomes are 6, we know. So that will be equal to 1 by 3. That's my answer. Otherwise we can write down the formula also, number of favorable outcomes by total number of outcomes, right? Which of the following cannot be the probability of an event? So it is a multiple choice question. A is 1 by 3, B is 0.1, C is 3%, and D is 17 by 16. So now we already know this concept that probability is always greater than or equal to 0 and it is less than or equal to 1. So we just have to check all the options. So this is my less than 0, this is also less than 0, and this is 3%. So 3% means 3 by 100. So this is also less than 0. But this is 1 by 16, right? So this is greater than 1, right? This value is greater than 1. So then this won't be a possibility, because in the question we see cannot. So just take care, cannot or yes or no, that those things sometimes we skip. So we know that my answer will be D 17 by 16. You should need to write both the things, the options as well as your answer. Okay, now question number 4. So question number 4 says, out of 200 bulbs, in a box, okay, 12 bulbs are defective. 12 bulbs are defective. Okay, one bulb is taken out at random. One bulb is taken out at random from the box. Okay, what is the probability? What is the probability that the drawn bulb is not defective. Guys, we have to pay attention. I know 1 mark question, so you really hurry, but not defective. Okay, so we know total outcomes are how much? 200. Then out of that 12 bulbs are defective. Okay, so not defective bulbs I'll write down. Those will be my favorable outcomes. So not defective bulbs will be how much? 200 minus 12. So that will give me 188, right? So those are not defective. So these are my favorable outcomes. So now I can say probability of an event is equal to number of favorable outcomes. 1 mark question, guys, I know, will over total number of outcomes. Okay, so now my probability of getting a not defective bulb, okay, not defective bulb will be equal to 188 by 200. So does it go by 4? 4 50s and 4 4s are 16, 4 7s are 28. Okay, so this is my answer. Okay, so 4 questions are over. Now let's move to question number 5. So question number 5 says an event is very unlikely to happen. An event is very unlikely. Very unlikely. It's like a near impossible event. Not totally impossible, but nearly. So an event is very unlikely to happen. Its probability is closest to. Okay, so not the exact value, but out of the options we have to find out closest to what. So 0.0001, B option is 0.001, C option is 0.01, and D option is 0.1. So closest will be means closest to 0, right? So out of these 4 options, my closest option to 0 is A. So 0.001. Other number, one more 0. Okay, so other options are greater than that. So now that's the answer. Now let's move to next question. So next question says question number 6, last 1 mark question of this test. A card is drawn at random. A card is drawn at random from a well shuffled, okay, deck, or we can say pack of 52 cards. Usually this is a normal deck. Okay, find the probability of getting neither, okay, remember this word, neither a red card nor a queen. So neither a red card nor a queen we do. Okay, so first we'll go to red cards. So in this question, how many red cards are there, right? So out of total number are 52. So I can write down in my solution that total number of cards now I don't want a red card, right? Neither a red card. So that means my favorable outcomes will include my black cards, right? So how many black cards are there? There are 4 suits, 2 suits of black and 2 suits of red, right? So 13 in each suit. So I'll have black cards will be 26, half of that, right? Now we don't want a queen also, right? So how many queens will be there in black cards? There are 2 suits, so there will be 2 black queens, right? So I'll say black queens will be there, which I have to subtract. There will be 2, one for spades and one for clubs. So that also I don't want it can't be queen, right? So it can't be red card, that we already omitted. So my favorable outcomes will be how much, right? Number of favorable outcomes will be equal to 26 minus 2. So that will be equal to 24. Okay, so now my probability of an event is equal to number of favorable outcomes by total number of outcomes. Okay, so now my probability of neither red card or nor a queen, right? So that will be equal to 24 number of favorable outcomes divided by total number of outcomes are 52. So 13 4s are 52 and 4 6 are 24. So 6 by 13 will be my answer. Okay, now so our 1 mark questions are over, all 6 questions. So now let's move to 2 mark questions. Okay, so we'll go to 2 marks questions now. 2 marks questions. Okay, now so that is the 7th question of this test. So 7th question of this test has a bag contains, okay, a bag contains cards with numbers written on it. Numbers written on it. So the numbers written on it are 1 to 80. Okay, now a card is okay, so a card is pulled out at random. Pulled out at random. Find the probability. Find the probability that the card shows that the card shows a perfect square. So we know perfect square, right? Okay, so a bag contains cards with numbers written on it 1 to 80. So it is not between 1 to 80. When they say the numbers are between 1 to 80, that is a different thing, but they are saying there are cards and numbers are written 1 to 80. So even one number card is there and 80 number card is also there. So all the numbers are included in this, because sometimes this is a confusion. So that's fine. Okay, now a card is pulled at random. You have to find the probability that it shows a perfect square. So now we'll write down total number of cards, or total number of outcomes are 80. Okay, now we'll talk about the favorable outcomes. So what are my favorable outcomes? We need to include all my perfect squares. So 1 square, then 2 square, then 3 square, 4 square, 5 square, 6 square, 7 square, 8 square, then 9 square will be greater than 81, right? So that will be greater. So only these will be my favorable outcomes. So now number of favorable outcomes will be equal to, we can count these. So 1 2 3 4 5 6 7 8. We know 1 square to 8 square, so we can just easily find out that number of favorable outcomes are 8. Okay, now my probability formula. So probability of an event is equal to number of favorable outcomes or possible outcomes. So different books might write down different, but it's fine anyway, by total number of outcomes. So this is an experiment and we are talking about this trial. So this is number of favorable outcomes are 8, right? Okay, I can write down here that probability of getting a perfect square number. Okay, so that will be number of favorable outcomes are 8 and total number of outcomes are 80. So this will be equal to 1 by 10. That's my answer. Okay, let's move to question number 8 now, right? Okay, question number 8 says a bag contains 6 red and 5 blue balls. Find the probability that the bulb drawn is not red. That the bulb drawn is not red. This has to be in clear. Okay, so now total, how many total balls? So total number of balls or total number of outcomes are 6 plus 5. So total there are 11 balls. So my total number of outcomes are 11. Not red. So there are only 2 kinds of balls. Correct. So now my favorable outcomes will be how many? Number of favorable outcomes I can write down. How many favorable outcomes? Not red. So they will be blue balls. So those will be equal to 5. Now I have to write down my formula. Probability of an event is equal to number of favorable outcomes by total number of outcomes. Total number of outcomes. So this is clear. Now I want probability of getting not red ball. So not red will be equal to 5 by 11. That's my answer. Easy. Now let's move to how many questions are done? 8. So now question number 9. Okay. So question number 9 says there are 30 cards. There are 30 cards of the same size. In a bag in which numbers 1 to 30 are written. In which numbers 1 to 30 are written. So it seems to be similar like the previous question. Okay, one card is taken out. One card is taken out of the bag at random. Find the probability. That the number on the selected card like which we picked out is not divisible by 3. Not divisible by 3. Okay, so there are 30 cards of the same size in a bag. In which numbers 1 to 30 are written. One card is taken out at random from the bag. Find the probability that the number on the selected card is not divisible by 3. Okay, so now my solution. Total number of cards again or total number of outcomes is equal to 30 because 1 and 30 cards are also there. Now there will be numbers divisible. Okay, so numbers divisible by 3 will be 3, 6, 9, 12 and 24, then 27 and 30. Even 30 will be included, correct? So numbers divisible by 3, but in our question we need non-divisible by 3. Okay, so how many numbers are there which are divisible by 3? will be equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 numbers which are divisible by 3 and total numbers are 3. So my favorable outcomes, or numbers not divisible by 3, because that has been asked in the question, divisible. Okay, sorry. So not divisible by 3 will be equal to 30 minus 10. So there are 20 numbers which are not divisible by 3. Now I'll write down my formula. Probability of an event is equal to number of favorable outcomes by total number of outcomes total number of outcomes. So what will it be? So probability of an event will be equal to, or I can write down probability of what? A number not divisible by 3, right? Probability of not divisible by 3 will be equal to 20 by 30. This and this gets cancelled, so 2 by 3 will be my answer. Okay, so now I think we have done all 3 marks questions. Now let's move to 2 marks questions. So now let's move to question number 10. So now we are starting with how much mark questions? So which color should I take? Okay, let me take yellow, or I'll take yellow. So yellow will be question number 10. So now we are starting with our 3 marks questions. Okay, so question number 10, right? So question number 10 says a bag contains cards. A bag contains cards numbered 1 to 49. Numbered 1 to 49. Okay. Find the probability. That the number on the drawn card is, okay, there are parts of this question. So first we have to find the probability that the number is an odd number. Then second part, you have to find out a multiple of 5, and third part is even prime. It should be even number also, and it should be prime number also. Okay, so there are 2 conditions in this. Okay, so a bag contains cards numbered 1 to 49. So how many cards are there? So total number of outcomes. So total number of outcomes are 49, because numbers are from 1 to 49. So both 1 and 49 are included. Okay, so now I'll write down the formula so that I don't have to write down in each part. So probability of an event is equal to number of favorable outcomes. So that will make my work easy, and total number of outcomes you can write down. So because you don't have to write down then for each and every part, same question, but if it is for different question, then you have to write down. Now I come to first part. So first part says an odd number. Okay, so how many odd numbers are there from 1 to 49? Cards are 1 to 49. So odd number are not multiples of 2, or I can say which are not divisible by 2. Correct? So 1, 3, 5, 7, 9, 11, 13. Then 15, 17, 19, 21, 23, then I have 25, 27, 29, 31, 33, 35, 37 and 39, then 41, 43, 45, 47 and 49, that is also included. Okay, so now how many numbers will be there? See, total are 49, but 9 and 1 are also included. So we know half of them will be, I know you can do it. So what you do, usually you will divide, because half of the numbers will be odd numbers. So you just divide 49 by 2 and then you just think about it. But in this, there is one more. 49 is also odd number and this is also an odd number. So there will be 25. You can count these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So there are 25 odd numbers. Okay, so just don't do like that. Like suppose if they ask even numbers from 1 to 49, how many will be there? 24. Okay, so it's not like 49 by 2 and you add 1 and here and there. So you can just think first, I have written all these numbers so that it becomes totally clear. So if you think you may make mistake or you can go wrong, so just write down all of them and then write down, instead of just doing 48 by 2 or 50 by 2 and then do it. So it depends on odd numbers and even numbers. So my favorable outcomes are 25 in this, right? So my number of favorable outcomes are 25. Okay, so now I have already written my formula. So my probability of an odd number, so probability of an odd number in this experiment will be equal to 25 and total number of cards are 49. So that's my answer. Okay, now let's move to second part. So second part says a multiple of 5. A multiple of 5. So how many multiples of 5 are there between this number? So my favorable outcomes or multiple of 5 will be equal to 5, 10, 15, 20, 25, 30, 35, 40, 45, right? Then 50 becomes my next. So how many are multiples of that? So 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 outcomes. Or I could just write down, I know multiples of 5, so 5 and 5 and 45 will be the last number, so it's 9 times. So we know that way also, but it's okay. Now I know probability of an event, or I'll have to write down a multiple of 5 in this experiment. Multiple of 5 will be equal to 9 by 49. That will be my answer. Okay, now third part says even prime. Okay, again we know that 1 is not a prime number. Okay, anyways, that whenever the prime number concept comes, I just tend to say this. Even prime means there is only one number is even, which is prime, right? So there is only one number. Okay, all other prime numbers are odd numbers except 2, correct? So there is only one number. So my favorable outcomes are only 1, correct? So probability of an event, or I can write down even prime number, will be equal to 1 by 49. So that's my answer. Okay, so we have finished 10th question. Yeah, that was my 10th question. Now I'll move to question number 11. Okay, that is also my 3-mark question. So let's move to 3-mark question. Okay, 2 unbiased coins. 2 unbiased. Okay, sometimes you might say that what are unbiased coins? Like we have not made it. Those are the normal coins which have head and tails on both the sides. Okay, so 2 unbiased coins are tossed simultaneously. Okay, find the probability find the probability of getting. So now it has also few parts. So my first part is at least one head. At least one head. Okay, second part says at most one head. Okay, good question. So your concept of at least and at most should be clear when we are doing this question. And then third is no head. Okay, so two unbiased coins are tossed simultaneously. Okay, so now in my solution I know what will be the options if I flip two coins or I toss two coins. So my probability of getting the coins will be tails, head, tail, 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 and then I can write down head, head, and head, head. Okay, so how many? This is my sample space. Okay, I did the wrong one. Okay, so this is my sample space, right? So my sample space shows that there are total number of outcomes are, how many are there? 4 outcomes, right? Okay, now this has to be clear that sample space, when you write down your options all become clear. Okay, now and we will write down that what is my probability of an event is number of favorable outcomes by total number of outcomes. Okay, so now this is clear. Now we'll move to each part. So first part says at least one head. Okay, so at least one head means there can be more heads other than one. Okay, so there can be 2 heads, 3 heads, but in this case there won't be 3, but I would say it can have more than one also. Okay, so how many options are there for this first question? So at least one head. So it will be this, this, and at least, so this also, right? So now my number of favorable outcomes, okay, or I can write down my options here also. At least one head will have how many outcomes? So I can write down, okay, my favorable outcomes, what will be they will be tail, head, head, tail, or head, head. All 3 options will be there, right? So there are total number of 3 outcomes. So my favorable outcomes are 3. So I can write down of at least one head, probability of getting at least one head will be equal to 3. Total outcomes are 4. So that's my answer. Okay, let's move to second part. So second part says at most one head. At most one head is maximum of 2. It won't have less than at most one head. So it won't have more than one head. Maximum it can have is one head, right? So least means it can have one more than that, but at most 2 means, at most 1 means it can have maximum of 1 head, right? But it can have 0 also, right? You are getting this point? So it can be no head also, but maximum of 1 head in whatever the outcomes are. So now suppose if I write down what will be my outcome. So my favorable outcomes will be at most one head, right? One head. So at most one head means this can be this can be this, and this can be this. So I can have 3 outcomes again. So at most one means it can have tail, head, it can have head tail, because in this it has one head, but at most means if it has no head also. So no head means it will be equal to TT. So there will be 3 outcomes also here. So sometimes the kids miss this below one head because they think head should be there at least. Okay, so in whole experiment I just have to figure out that it can have with no head also. So my favorable outcomes are 3 outcomes. So now I'll write down probability of getting at most one head. Okay, so that will be also equal to 3/4. That's my answer. Okay, now third part is no head. Okay, no head means which is the outcome which has no head? This has head, this has head, this has head. So only one outcome, right? So my favorable outcome will be equal to tail, right? So favorable outcome will be equal to tail. So now only one outcome out of 4 outcome, right? So we just have tail which has no head in it. So now my probability of no head will be equal to 1/4, right? Okay, so now we are done with our 3-mark questions. So that was we have one more. Okay, so now let's do question number 12. So more of 1-mark question. Okay, so now this is 3 different coins are tossed together. So now we have 3 coins. So 3 different coins are tossed together. Find the probability. Find the probability of getting. Okay, now this also has options. So first part is asking exactly 2 heads. Exactly 2 heads. Second, they are asking at least 2 heads. At least 2 heads. Third is at least 2 tails. Okay, so 3 options are there for this question. Now first, for this kind of question, first we have to write down my sample space, definitely, that what will be the outcomes. I have to know these outcomes. So 3 coins are there. Okay, so there will be how many outcomes now? Let's see. So there will be tail. Okay, then tail, head, then head, tail. Okay, then tail, head, tail. I just left the space so that I can explain you better. So tail, head, then I have head, tail, head, tail, then head, then head, tail, and tail, head. Right, so how many? 1 2 3 4 5 6 7. One more, guys. So that will be equal to head, tail, head. So those are the, and we know there are 8 outcomes after doing we have done the formula also in the concept. So there will be like if I toss one coin, there will be 2 outcomes, and there are 3 coins, so this will be the power of that. So there will be total 8 outcomes in this case. So I can figure it out. Tail. Okay, so 3 3 6 2 8. So now this is my sample space. Okay, and how many outcomes are there? So total number of outcomes are 8. Okay, we have to write down the sample space because we have to do different questions based on this. Okay, now I'll move to my same color. We are doing 3-mark questions. Okay, so now first I'll write down my formula also beforehand, so I don't have to write down for each part. So number of favorable outcomes by total number of outcomes. Okay, so now first part. Okay, so first part, exactly 2 heads. Okay, so what are the favorable outcomes from this? Exactly 2 heads. Tell me. Exactly 2 heads means not more than that and not less than that. So not till here. So we have HHT and HTH and THH. So these are my favorable outcomes. So 2 heads, 2 heads, 2 heads. Otherwise this has 3, this has 1, 1, 1, 1 and no head. So only these 3 outcomes. So 3 outcomes are there for this one. So now I can write down my answer. So probability of getting exactly 2 heads will be equal to 3. Total outcomes are 8. So that's my answer. Okay, second part says at least 2 heads. At least 2 heads. So at least 2 heads means it can have more than 2 heads, right? So at least 2 heads means this doesn't have any head, this no. So it can have 3 heads also. So all the outcomes, head, it's at least 2 heads. HHT, HTH, I'm just copying from the previous part. I can see that page, right? So THH. So these are my 4 outcomes which have at least 2 heads. So my answer or probability of getting at least 2 heads, okay, so that will be equal to 4 by 8. So 1 by 2. So that's my answer. Let's move to third part. So third part says at least 2 tails. At least 2 tails, right? So it can have more than 2 tails. Okay, so I'll have this TTT, this and this. So 4 outcomes, same like for at least 2. So let's see. I'm just seeing from that. So 2 tails options, favorable outcomes. Okay, so favorable outcomes will be equal to TTT, then I'll have TTH, and then I can have THT, and then HTT. So all these have at least 2 tails, correct? So there are 4 outcomes for this also. So my probability of at least 2 tails will be equal to 4 by 8. Total outcomes are 8, right? We have already done. So now 1 by 2. That's my answer. Okay guys, so we are done with our 3 marks questions. So we'll move to 4 mark questions now. So can I take another color? Okay, let's take this one. Okay, so now we are starting with 4 marks questions. Okay, so that question, how many we have done? We have done, I think, 12 questions. So 4 mark questions. So question number 13. So question number 13, it says cards marked with numbers. Cards marked with numbers 3, 4, 5 up to 50. So my card starts from 3. Don't do 50 minus 3. 3 is also included. A card is marked 3 to 50. So 3 is also included. Okay. Are placed in a bag and mixed thoroughly. Okay, one card is drawn at random. One card is drawn at random from the bag. Okay, now find the probability. Find the probability that the number on the card is, that the number on the card is, okay, it has parts. So first part says divisible by 7, divisible by 7. Second part says a perfect square, okay. Third is a multiple of 6. Okay, so this is the question. So now it says cards are marked with numbers 3 to 50. Okay, so my total outcomes are 48. Okay, so don't make mistake here only, otherwise this whole question will be wrong. All your 4 marks are gone if you make a mistake here, because there is a 3 numbered card also, through 3, 2 and 50 is also there. So there will be 48 cards, right? So total number of outcomes are these. And let's write down the formula first. So probability of an event is equal to number of favorable outcomes by total number of outcomes. Okay, now I'll move to different parts. So divisible by 7, so my outcomes will be what? Let me see what are the outcomes. See, it starts with 7 numbered card will be there. Outcomes will be equal to 7 to the 14, 7 to the 21, 7 4 to the 28, 7 5 to the 35, 7 6 to 42. Then 49 will not be there. All multiples of 7 I am writing. So 49 is also there. There are cards up to 50. Right? I was looking at this 48, so fine. Now 7 to 49. So how many are there? 1, 2, 3, 4, 5, 6, 7 we know. So there are total number of outcomes are 7 outcomes. Okay, so this is their favorable outcomes, correct? So now my probability of getting a numbered card which is divisible by 7 will be equal to 7, and total number of cards are 48. So that's my answer. Let's move to second part. So second part says a perfect square numbered card. Okay, so how many outcomes will be equal to? Which will be the perfect square? 1 is not there, so I will not include that. I will start from 4, then 3 square is 9, 4 square is 16, 25, 36, and 7 7 ja 49, right? So 2 square, 3 square, 4 square, 5 square, 6 square, 7 square. Then 8 square gets more than 50. So we don't want that. So only there are favorable outcomes are. Therefore, favorable outcomes are how many? 6, right? Okay, so now my probability of getting a perfect square card will be equal to 6 by 48. So 6 1 ja 6 8 ja, so 1 by 8. That's my answer. Okay, now third part. So third part says a multiple of 6. So multiple of 6, let's see. So first it will start. So now my favorable outcomes will be 6 18, 6 4 24, 6 5 30, 6 6 36, 6 7 42, 6 8 48, right? Then 50, it won't be there. So all these are my favorable outcomes which are multiples of 6. So how many? 8, right? So there are I can say number of favorable outcomes are 8. Okay, so now my probability of an event. So what is the event here? Multiple of 6. So this will be equal to 8, and total outcomes are 48. right? So this will be equal to 8 1 by 8, 8 1 by 6, right? So that's fine, I think. Okay, now that's all. What does it say now? Next question, multiple of 6. That's done. Now let's move to different questions. So next question is question number 14, second last question, guys. Okay, so what does it say? It says a box contains cards bearing numbers from 6 to 70. Okay, if one card is drawn at random from the box, find the probability that it bears. Okay, there are different parts. So now first part is a one digit number. Second part says a number divisible by 5. Third part says a odd number less than 30. An odd number which is less than 30. Okay, then we have a composite number. Guys, all your knowledge, you have to know what are composite numbers, right? A composite number between 50 and 70. So prime number, composite numbers are those numbers which are not prime, and one is neither prime nor composite, we have to remember. Okay, so now this is my question. A box contains cards bearing numbers from 6 to 70. Okay, 6 card is also included, so there will be how many cards? 65 cards, right? 70 minus 5, because 1 to 5 cards are not there. So 6 to 70. Okay, solution. So total number of cards or total number of outcomes. So that will be equal to 65. Correct? So it starts from 5. You can 6 you can count. So 5 cards are not there till 60. So there are 65 cards. Okay, now one card is drawn at random from the box. Find the probability that it bears. Okay, so now I'll write down my formula of probability. So probability of an event is number of favorable outcomes by total number of outcomes. Okay, now I'll move to different part. So different part says one digit number. Okay, so card, if we draw a card, then what is the probability that it bears a one digit number? Okay, so one digit number, how many outcomes are there? It starts from 6, right? So my favorable outcomes will be equal to 6th card is there. So 6, 7, 8 and 9. That's all, because then it starts from 2 digit number. So there are 4 outcomes. Okay, so my probability of getting a one digit number will be equal to 4, and total outcomes are 65. So 65, that's the answer. Now for second part, it says a number divisible by 5. A number divisible by 5. Okay, so it starts from 6, so 5 is not there. So my favorable outcomes will be 5 is not there, but 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, 5 6s are 30, 5 7s are 35, 5 8s are 40, 5 9s are 45, 5 10s are 50, then 11, then 60, 65, and 70 is also there. 70 numbered card is also there, right? So now how many? 13, right? So there are total 13 outcomes. So there are 13 outcomes for this experiment. In this experiment, so number of this, so probability of event, or I can write down which is getting a number divisible by 5 will be equal to 13. Total outcomes are 65. Okay, so 13 is 13, 13 5s are, so 1 by 5 will be my answer. Okay, now third part. So third part says an odd number less than 30, an odd number which is less than 30. Okay, so my favorable outcomes. So now we have to figure out from these numbers that it should be odd also and it should be less than 30. So favorable outcomes, it starts from 6, so 6 is not an odd number. So 7 9 11 13 15 17 19 21 23 25 27 and 29, less than 30. So 30, and anyway 30 is not an odd number also. So but suppose if it was 31, then less than means we don't have to include 31 because it is not equal to 31, it is less than 31. Okay, so that will be 29 if the question was like that. So odd number as well as this. So how many numbers are there? 5 8 9 10 11 12 numbers are there, 12 outcomes. Okay, 6 7 8 9 10 11 12, so there are 12 outcomes for this. So now my probability of getting an odd number which is less than 30 will be equal to 12, and this is equal to 65. So that's my answer. Okay, now fourth part says a composite number. Okay, a composite number between 50 and 70, between 50 and 70. So composite which is not prime. Okay, so let's do favorable outcomes will be, see, we'll start from 50. So 51 is divisible by 3, then 52, any even number won't be okay, sorry, we have to do the composite numbers. So between, so we are not including 50 and 70. Between means we have to start from 51 and we have to stop at 69. So we can say 51 is not prime, so it is composite. Then 52, all even numbers will be composite numbers, right? Then 53 is prime. Okay, then 54 55, okay, so composite number. So 53 is prime. Then 56 57, right, it goes by 3, so it's a composite number. Then 58 definitely. Then 59 is prime. Then 61 is prime. 62 63 64 65. Then okay, so we know from this that there are total outcomes. So total favorable outcomes I can say. So total number of favorable outcomes are 15. So my probability of composite number between 50 to 70 will be 15, and total number of outcomes are 65 we know. So this will be equal to 5 3s and 13. So my answer will be equal to Okay guys, so question number 15. A bag contains cards numbered 1 to 20. A card is drawn at random from the bag. Find the probability that the number on the drawn card is. So there are parts for that. So maybe the probability of a prime number. Then second part is a composite number. Okay, and the number divisible by 3. So a number divisible by 3. Okay, so now let's see how many cards are there. Okay, so let's move with the solution. So total number of cards are they are numbered 1 to 20. So 1 is included, 20 is included. So there are 20. Okay, now it is drawn at random. Find the probability that the number drawn is. Okay, so let's write down the formula first. So number of favorable outcomes by total number of outcomes. Okay, so now first part, I'll move to the first part, a prime number. Okay, so now let's see. So again I would say that 1 is not prime nor composite, so we'll just move to prime numbers. So what are the prime numbers? We have favorable outcomes as 2 is prime, then 3, then 5, then 7, 9 is not, then 11, then 13, 15 is not, then 17, 18 is not, 19. Okay, so these are my favorable outcomes. So 19 is 1, then we have 20 is not. Okay, so how many are there? 3, 3, 6, 2, 8 outcomes. So my favorable outcomes are 8 outcomes. So 6, 8, right? Okay, so now my probability of getting a prime number in this experiment will be equal to 8, and total outcomes are 20. Okay, so 4 2s are 8, 4 5s are 20, so 2 by 5. That will be my answer. Okay, let's move to second one. So second one says a composite number. Okay, so what are composite numbers? Which are not prime, and we can't subtract 20 minus 8, right? Otherwise then 1 will also be included in that. So my composite numbers are other than prime numbers except 1. So total numbers are 8 prime numbers, correct? So my favorable outcome or my composite numbers, I can just do like that. Either I can write down the number. So 1 is not, because these are a few numbers. So either I can do like that I can write down 4, 6, 8, 9, 10, 12, 14, 15, then 16 and 18. So 3, 3, 6, 7, 8, 9, 10. There should be one more. So 1, 2, 3, 4, 6, 9, 10, 12, 13, 14, 15, 16. Okay, 20 is also there, right? Yeah. So there are 4, 3, 7, 8, 9, 10, 11. So total are 11 outcomes. Or I can do like that I can subtract 20, right? I can subtract from 20. Okay, so there are 8 prime numbers, so I'll subtract 8 from 20, so I'm getting 12, but those 12 are including 1, correct? But 1 is not neither prime nor composite, so I'll say 12 minus 1 also, then again I'll get 11 outcomes. So any of the way you can consider to find out your composite numbers in this question. So now then I can see that probability of getting a composite number will be equal to 11 by 20. Okay, now third part. So third part says a number divisible by 3. A number divisible by 3. Okay, so let's see our favorable outcomes. What are they? So my favorable outcomes are, it starts from 1, but divisible by 3 means it will be 3, then 6, 3 3 is 9, 3 4 is 12, all multiples of 3, 3 5 is 15, 3 6 is 18, then 3 7 is 21. So we have cards up to 20 only. So my number of favorable outcomes are 6 outcomes. Okay, so now if I write down a formula, so number divisible by 3, so that will be equal to 6 by 20. So 2 3s are 6, 2 10s are 20, so 3 by 10, that will be my answer. So this finishes our test. I think you enjoyed doing the test with me.